So continuing on with the matrix operations. So the next operation that we need to know about is multiplication by a scalar. So basically, if you have a scalar number or a constant C, then you can multiply any matrix by it, C times A, and what it basically does is it multiplies every element of the matrix by that scalar, which basically means each element CA12 all the way to C times A1n all the way down to CAM1, CAM2, CAMN. And again, the scalar multiplication follows similar properties like the properties we discussed for addition and subtraction. So if you have two matrices which you can add A and B, so C times A plus B can be CA plus CB, as you would normally expect for any kind of scalar operation. If you have two constants C1 and C2, so adding these two and multiplying by A would be the same effect as if you pre-multiplied by A by C1, pre-multiplied it by C2 and then added them together. And if you are multiplying two scalars C1 and C2 and then multiplying the matrix A by it, then the order doesn't really matter. So you could do C2 times C1 times A, you could also do C1 times C2 times A. Let's take a worked out example here. So here's an example of matrix operations. Let's say I give you a matrix A as 2, 4, 6, 8, 10, 12, and I also give you a matrix B as 0, 8, 12, 10, 0, 4. And the question is, find a matrix C such that it satisfies this condition: A plus 2C equals B. Well, how do you do that? Pretty simple. So 2C equals B minus A. You know B, you know A, so simply do the operation. So it's doing it on an element by element basis would be 0 minus 2, 8 minus 4, then 12 minus 6, 10 minus 8, then 0 minus 10, and 4 minus 12. That would give you minus 2, 4, 6, 2, minus 10, minus 8. And then, so you've got the value of 2C here, and so to get C, you have to do half of this number, this matrix, I'm sorry. And using the rules of scalar multiplication, you just divide each element by 2, and you have your value of C, which is minus 1, 2, 3, 1, minus 5, minus 4. So as you can see, if you follow it step by step, operations on matrices are pretty simple and straightforward. as long as you keep the order correct. So that is why in all matrix operations, keeping the order correct is extremely important. And as we go into more complex matrix operations, such as finding the inverse or using matrices to solve systems of linear equations, you will see that one single mistake in getting the order correct between operations might lead you to a totally wrong answer at the end. So whatever you do, keep the order correct, which means that if you're doing operation on B21, you can only compare it with A21 and so on. So let's move on. So you might be wondering, we've done addition and scalar multiplication, but what about multiplying two matrices? Is that possible, or is that even a thing? Well, yes, again, under certain conditions you can multiply matrices. So here we are going to look at multiplication of matrices. So let's start off again with the general form: A equals Aij m by n, B equals Bij p by q. So then the product A times B is defined if and only if n equals p, which means that the number of columns of A must equal the number of rows of B. Only then this product, the new matrix A times B, is defined. Note that even if this is defined, the converse may not be true. So if A times B exists, B times A may or may not exist. So B times A exists if and only if Q equals M, which means that the number of columns of B must equal the number of rows of A. And well, how do you find that? So let's say the new matrix that you are trying to compute, C equals A times B, is a new matrix Cij m cross P. So the dimensions of the new matrix are m by P. So it's the number of rows of A and the number of rows of B. And that is given by the summation k equals 1 through n Aik Bkj, where I goes from 1 through m and j goes from 1 through p. So here, rather than simply looking at the formula, it's easier to understand if we actually look at a worked out example. So let's take an example. Oh, yeah.
So I think you can just erase this C equal to A cross B. Start and I will edit this part out.
Yeah. Oh, this part, right?
Yeah,
Yeah.
M cross, I think it's an M cross Q, right? So what I'm saying is you can, I think you can just say let's C equal to A cross B.
Yeah.
And then repeat this.
Oh,
and
okay,
edit
yeah.
the rest of this part out.
Yeah. Good catch, actually. Yeah. Good, you're paying attention.
Always pay some attention because
Yeah.
otherwise like
This is leaving some nasty strains. So C equals A times B is defined as, in the general form, Cij M cross Q. So the number of rows of A and the number of columns of B, and that is given by the summation Aik Bkj with the summation index k running from 1 through n, where I goes from 1 through m and j goes from 1 through p. So instead of simply looking at the formula, it will be easier for us to understand how this works if we look at a worked out example. So let's do an example. So let's say you have a matrix like A. It's a simple matrix with only one row, 2 and 7. And then you have a second matrix B, which is a 2 by 2 matrix, 1, 3, minus 2, 0. So the question is, first of all, is A times B defined? So the way to check it is if n equals p. So the number of columns of A equals the number of rows of P. In this case, A has 2 columns and B has 2 rows. So that means n equals p is satisfied. So we know that A times B is meaningful or makes sense. And so then how do we calculate that? So let's say C equals A times B. And then you have to apply this formula. So it's each element of A from each row times each element of B from each column. So 2 times 1 plus 7 times minus 2, then 2 times 3 plus 7 times 0, that is the multiplication matrix. And so finally your C is minus 12 and 6. Now a thing to wonder about is BA defined. Can you do the converse? And I'll leave it to the listener to figure out that BA is undefined. Think about why you cannot calculate that. Similarly, here's another example. If you have P equals 0, 4, 2, 8, 5, minus 3, and then Q equals, let's say, 1, 2, 3. I'll leave it to you as an exercise to show that both PQ and QP undefined. So again, while doing the matrix multiplication operation, it's important to first determine, using these rules, whether the product actually exists or not. And if it exists, to follow this formula in the right order. So keeping the order of the elements the way it should be is extremely important for you to get the right answer.